Hello everyone, in the following video I will show you how to solve the Towers of Hanoi with the help of recursion. This will be shown in 3 parts. At first, we have a look at the Towers of Hanoi. The game consists of 3 rods and in this example 3 discs. The goal of the game is to move all discs from the starting rod to the end rod stacked up correctly. The rules are the following: you're not allowed to put a bigger disc on a smaller one, and you can only move one at a time. To see how it works, we go through it step by step. In the first move, we move the top disc to the third rod. In the second, we move the top disc from the first rod to the second rod. Next, we stack the disc from the third rod onto the second rod. In the fourth, we take the remaining disc from the first rod and drop it onto the third rod, which is the final destination for the disc. Now we transport the top disc from the second rod to the first one, so we can move the underlying disc and the next move onto the third rod. In the 7th turn, which is also the last one, we take the remaining disc from the first rod and relocate it to the third rod. With that action we finish the game, as the discs are now in correct order and at their destination. Now, as we know how the Towers of Hanoi work, we'll move forward to step 2 to understand how recursion works. So, what is recursion and what do we use it for? A recursion is an object-oriented programming, a calling of the same function in the function itself. We can solve that way problems by looping through the function's multiple instances. To see that and understand what it does, I create now a small recursive program where it basically just counts down. I start with creating a function which expects a variable, which I call n. In the function, I create an if-else statement. The if gets triggered as soon as n equals 0. So we have an exit of the recursion, otherwise it would loop infinitely and causes a stack overflow. So please keep in mind to set a breakpoint of any form if you use a recursive function. Now add the basic logic in the else section, which is first an output of the current number so we see where we are. Next, we call the function itself, but we decrement it every time it calls itself. So this is the recursion as it calls itself. I quickly add an input to the main so we can choose how often it should run through and execute now the program. I enter now the 5 and it runs through it 5 times and breaks at the 0. I hope you now understand the basics of recursion and how it can help you to solve problems which would be harder if you use a normal loop. In this part, which is also the last part, I will show you the recursion action and how it solves the Towers of Hanoi. I already prepared the basics, including the basic input and the calling of the Hanoi function. I also created for the Hanoi function 4 variables: the number of disks, the source, that's the starting point, transition, the middle point, and the destination. Now we focus on the recursive function. As I showed before, it's important to set a break so we can escape the endless loop and prevent a stack overflow. The if is true if the number of disks equals 1, and so we'll enter that part of code. As we know that the last move is to move the disk from the source to the destination, we will define that here as an output with its variables, and then break out of its instance of the recursion. Now to the basis. As we have 3 rods, the source, transition, and destination, we need to call the function 2 times extra, so we represent those rods. We move so the variable names in those self-instantiated calls one step to the right, so the virtual plate gets moved from the left to the right. Now let's execute it and have a look in the debugger how it actually runs through it, and you get a better understanding of it. What it basically now does is that it steps into the function, sees the disk are equal to 3, then it gets into the first instance of itself, there it gets decremented now to 2. Then it steps again in itself, gets decremented again, and now it breaks in this third instance, because it's now equal to 1, which means it writes down that disk 1 goes from A to C. As the third instance is done, we're back in the second and now onto the output, which puts out with disk 2 from A to B. Now it goes into the third, which decrements it again and writes down move disk 1 from C to B. Then we'll break out of the second instant back into the main one, where it just ran through the first self call and writes down move disk 3 from A to C. This will now repeat and goes on till it gets back to the first call and breaks. And now we have again the 7 moves we saw at the beginning in part 1. I hope you learned something. See you next time.